Hello guys, welcome aboard Apex Math. My name is Bino. In this video, we go through question 4 from the 31st July 2025 and 5 mathematics question paper. Question 4.1.1, we evaluate the following integral, and since the degree of the denominator is greater than the degree of the numerator, we must not get tempted to use the partial fraction decomposition. We can still evaluate this integral using the u-sub method, where we let u to be equals to the 2x squared minus 2x plus 5 in the denominator. So, ladies and gentlemen, we let u to be equal the 2x squared minus 2x plus 5, and we differentiate the u with respect to x. So the derivative of the u with respect to x will be the 2 multiplied by the derivative of x squared, which is 2x, minus 2 multiplied by the derivative of x, which is 1, and the derivative of that 5 will be 0. And the derivative of the u with respect to x will be equal. So the reason why we used the u-sub method is because when we take the 2 as our common factor, we have 2 into 2x minus 1, and that 2x minus 1 is also appearing on our integrand. So that's why we used the u-sub method, because that 2x minus 1, we have it, and that dx. So let's make the 2x minus 1 and that dx the subject of the formula, and also group the 2 and that du on the left hand side. So we are going to multiply both sides of the equation by the dx, and also divide both sides of the equation by the 2. On the right hand side, that 2 divided by that 2 will be 1, and the dx divided by the dx on the left will be 1, such that we have du divided by 2 on the left, which will be equals to the 2x minus 1 multiplied by the dx. So in the place of the 2x minus 1 multiplied by the dx, in that place of the 2x minus 1 multiplied by the dx, we'll substitute du over 2, and in the place of the 2x squared minus 2x plus 5, we will substitute the u. We have the integral, but in the place of the 2x squared minus 2x plus 5, we substitute the u, and the 2x squared minus 2x plus 5 is squared, so even the u will be squared. And in the place of the 2x minus 1 dx, we substitute du divided by 2, and that 1 divided by 2 is a constant. We can factor it out of the integral since it won't affect the integration process, and that u squared, we move it from the denominator to the numerator, and its exponent will change sign to negative 2. So when we integrate this, so we have half the integral of u to the power negative 2 will be u to the power negative 2 plus 1. We also divide by the new exponent, the negative 2 plus 1. This will be equal the 1 over 2 multiplied by u to the power negative 2 plus 1 is negative 1, divided by negative 2 plus 1, which is negative 1. And from here, we have that negative half. We move that u to the power negative 1 from the numerator to the denominator, and the exponent will change sign to positive 1. And from here, we can bring back, so we have negative 1 over 2. And we bring back the u, so we said that the u is equal 2x squared minus 2x plus 5. So in the place of the u, we substitute back the 2x squared minus 2x plus 5. This will be equals to negative 1 divided by 2 multiplied by 2x squared is 4x squared. So we distribute that 2. So we have 4x squared minus 4x plus 10 after distributing the 2. So you can leave your answer there or there. So this will be our answer for this first question. Question 4.1.2, we evaluate the following integral, and it will be much simpler for us to break down the cos cube x than it will be for us to break down the sine to the power 5x. So we have the integral of sine to the power 5x. We break down the cos cube x and express it as cos squared x multiplied by cos x dx, and we are going to use the trigonometric identity sine squared x plus cos squared x is equal 1, and we make the cos squared x the subject of the formula. So we have cos squared x is equal 1 minus sine squared x. So in the place of that cos squared x, we are going to substitute 1 minus sine squared x. So we have the integral of sine to the power 5x, and in the place of this cos squared x, we are going to substitute 1 minus sine squared x multiplied by the cos x dx. So from here, we are going to let u, so we let u to be equal sine x, and the derivative of the u with respect to the derivative of x will be equal the derivative of the sine x, which is cos x. We have cos x and dx there, so let's make this cos x and that dx the subject of the formula. So we multiply both sides by dx, and on the left that dx and the dx will cancel out, and our du will be equal cos of x multiplied by dx. So we'll substitute the du in the place of that cos x dx. So we have the integral of u in the place of the sine x. Remember that we said that u is equal sine x. So the sine is raised to the power 5, even the u will be raised to the power 5 of 1 minus sine squared, but in the place of the sine we have u. Since the sine is raised to the power 2, even the u will be raised to the power 2. And in the place of the cos dx, we are going to substitute the du, since the du is equal the cos x dx. So we have the du in the place of the cos dx. This will be equal, so u to the power 5 multiplied by 1 will be u to the power. So we distribute that u to the power 5. So u to the power 5 multiplied by 1 is u to the power 5. U to the power 5 multiplied by u to the power 2. 5 plus 2 is 7. So we have u to the power 7 du. The integral of u to the power 5 will be u to the power 5. We add 1 to the exponent. We divide this whole by the exponent, the new exponent, the 5 plus 1. The integral of u to the power 7 will be u to the power 7 plus 1. We add 1 to the exponent and we divide by the new exponent, the 7 plus 1 plus our constant c. This will be equal u to the power 5 plus 1. 5 plus 1 is equal to 6. Even in the denominator, 5 plus 1 is 6. 7 plus 1 is 8. So we have u to the power 8 divided by 8. We bring back the sine x in the place of the u. Remember, we said that u is equal the sine x. So in the place of the u, let's substitute back the sine x. So we have sine in the place of the u is raised to the power 6. So even the sine will be raised to the power 6 divided by 6. So we have the plus c there, minus u to the power, sign in the place of the u to the power 8 divided by 8 plus the constant c, and this will be our answer for this second question. Question 4.1.3, we evaluate the following integral, and since the degree of the numerator is greater than the degree of the denominator, we are going to use the long division method. So we have the 2x plus 3, and inside we are going to have the 2x to the power 4 plus x cubed plus the x squared. And I have to stress that we have to write this in standard form so that we can get the correct answer. So we have to include the positive 0x and also the negative 2. So from here, we have to take the first term, the 2x to the power 4, and divide it by the 2x. So 2x to the power 4 divided by 2x is equal x to the power 3. We take the very same x to the power 3, we multiply it with the 2x plus 3. So x cubed multiplied by 2x will be equal 2x to the power 4. X cubed multiplied by 3 will be equal 3x cubed. And now we minus 2x to the power 4 minus 2x to the power 4 will be 0, and x cubed minus 3x cubed will be equal negative 2x cubed. Now we bring down the x squared. We bring it with its sign. So we have positive x squared. So now negative 2x cubed divided by that 2x will be equal negative x squared. We take this negative x squared, we multiply it with the 2x plus 3. So 2x multiplied by negative x squared will be equal negative 2x cubed. And also the negative x squared multiplied by positive 3 will be equal negative 3x squared. From here we minus negative 2x cubed minus negative 2x cubed will be 0. The x squared minus negative 3x squared will be equal positive 4x squared. And we bring down the 0x. So it's essential that we include the 0x. So we include the 0x. From here we have the 4x squared divided by 2x, which will be equal positive 2x. That 2x multiplied by 2x plus 3. So 2x multiplied by 2x will be equal 4x squared. It's not necessary to include the zeros, so in fact let me remove the zeros. So that 2x multiplied by that 3 will be equal positive 6x. Now we minus, so 4x squared minus 4x squared will be 0, so we don't have to write the 0, but the 0x minus 6x will be equal negative 6x. And we bring down that negative 2. So that negative 2, we bring it down. Now this negative 6x divided by that 2x will be equal negative 3. we take the very same negative 3, we multiply it by the 2x, and this will be equal negative 6x, and the negative 3 multiplied by positive 3 will be equal negative 9. So now we minus negative 6x minus 6x will be 0. Negative 2 minus 9 will be equal positive 7. The positive 7 will be our remainder since we have nothing to bring down. So our answer will include x cubed minus x squared plus 2x minus 3 plus the remainder divided by the 2x plus 3. So we have this as our final answer. So let me paste it here. So we have this as our answer, but it also has to include the remainder, which was 7. This remainder of 7, we divide it by the denominator, the 2x plus 3. So we have the 7 divided by the 2x plus 3 dx. So the left hand side is equal to the right hand side, but it will be much simpler for us to integrate the right hand side since we performed the long division. Now we can integrate, so the integral of x cubed will be x to the power 4 divided by 4, and the integral of x squared will be x to the power 3 divided by 3 plus the integral of 2x, which will be equal to x squared divided by 2. The integral of negative 3 will be negative 3x plus the integral of 7 divided by 2x plus 3. The 7 is a constant, we just put it by the side, and the integral will be the ln of the 2x plus 3. Remember that when we differentiate, we multiply by the derivative of that 2x, which is 2. Now we integrate, so we multiply by the derivative of the 2x, which is 2. If you are not able to follow through, you can evaluate the integral of the 7 divided by the 2x plus 3 by the side. So we have the integral of the 7 divided by the 2x plus 3 dx. We can factor out the 7 since it won't affect the integration process. So we have 1 divided by the 2x plus 3. I'm gonna leave this to you guys to use the u-sub method and let u equal the 2x plus 3 to determine the integral of 7 divided by 2x plus 3. Question 4.1.4, we have a product of two functions and we can't use the u-sub method. We are going to use integration by parts. So let's define our I-lathe rule from integration by parts. Remember that the I stands for the inverse trigonometric function, and the L stands for the logarithmic function, and the A stands for algebraic function, while the T stands for trigonometric function. So we have inverse trigonometric function and the trigonometric function. The E stands for exponential function. So let me write the formula for integration by parts. Remember the formula for integration by parts, we have the integral of f of x multiplied by g prime of x dx, which is equal f of x multiplied by g of x minus the integral of g of x multiplied by f prime of x dx. This formula for integration by parts correspond with our integral x log base 3 of 4x. So we have to determine which one between the f of x and the g prime of x will be equal to x, and which one will be equal to the log base 3 of 4x. So we have to determine which one will be equal the f of x and which one will be equal the g prime of x between the x and the log 4 base 3. So now the a stands for algebraic function, so that a stands for the algebraic function and the x represent that a. And the log stands for the logarithmic function represented by that letter L. So the letter L represents the logarithmic function, and on the islate we have that L. So the first letter that we come across going to the right will be the f of x, and the L is the first letter. So that first letter L represents the log of 4 base x, which will be the f of x. So the f of x will be the log of 4x base 3, and the g prime of x will be equal the x. So the formula for integration by parts has f prime of x. To determine that f prime of x, we have to differentiate the f of x. So the derivative of the f of x is the f prime of x, and the formula for integration by parts has g of x, and we only have g prime of x. To determine the g of x, we integrate the g prime of x to get the g of x. The integral of the g prime of x, the integral of the x will be x squared divided by 2, and the derivative of the f of x to get the f prime of x will be 1 divided by the ln of the base. The base is 3, so we have ln 3, and we just put that inner function, the 4x, in the denominator as it is, and we multiply the numerator with the derivative of the inner function. The derivative of the 4x is 4, so we multiply by 4, but then the 4 divided by that 4 will be 1, so we can remove the 4 over 4 such that we are left with 1 divided by the ln of 3x. Now, ladies and gentlemen, we have the integral of x multiplied by the log of base 3 of 4x dx equal the f of x multiplied by g of x. From that formula we have f of x multiplied by g of x, but let's start with the g of x. So we have x squared divided by 2 multiplied by the log of base 3 of 4x minus the integral of g of x multiplied by the f prime of x. So we have that, and we already determined the f of x multiplied by the g of x. So now the g of x is the x squared divided by 2, and the f prime of x is 1 divided by ln 3 of x. So we have x squared divided by 2 multiplied by 1 divided by ln 3 multiplied by x dx. From here we have the x squared multiplied by the log base 3 of 4x, but then the x squared is divided by 2 minus, so that x squared divided by x will be x. So we have minus the integral of x divided by 2 ln 3 dx. So now we have x squared divided by 2 multiplied by the log of base 3 of 4x. We can factor out the 1 divided by 2 ln 3. So we have 1 divided by 2 ln 3 multiplied by the integral of x dx. Finally, we have the integral of x multiplied by the log base 3 of 4x dx equal x squared divided by 2 multiplied by the log base 3 of 4x minus 1 divided by 2 ln 3. The integral of x is just x squared divided by 2, but then that 2 multiplied by 2 is 4. So we have 1 multiplied by x squared divided by 4 ln 3 plus the constant c. And this will be our answer for this question. Question 4.2, we have to evaluate the following integral, and since the degree of the denominator is greater than the degree of the numerator, we use partial fraction decomposition. So let's separate the integrand and factorize the denominator. So in the numerator, we have the 2x plus 7, and factorizing the denominator, the factors of the x squared is x, and x, the factors of the negative 2 will be positive 2 and negative 1. So now let's decompose. Since the factors are unique, the decomposition will be equal a divided by the first factor, the x plus 2, plus b divided by the second factor, the x minus 1. So from here, we have to determine the numerical value. We have to determine the numerical value of the a and the b. We multiply both sides of the equation by the denominator on the left. So we multiply both sides of the equation by the x plus 2 multiplied by the x minus 1. So even on the left, we multiply by the denominator on the left, the x plus 2 multiplied by x minus 1. And we can see that x plus 2 and that x plus 2 will cancel out. X minus 1 and the x minus 1 will also cancel out, such that we'll be left with 2x plus 7 is equal. So we have to distribute the x plus 2 multiplied by x minus 1. So we have a divided by the x plus 2, which we multiply with. So we distribute that x plus 2 multiplied by x minus 1. So this will be multiplied by x plus 2 multiplied by x minus 1 plus the b divided by x minus 1, which we also multiply with the x plus 2 multiplied by the x minus 1. And we can see that the x plus 2 and that x plus 2 will cancel out, and there the x minus 1 and the x minus 1 will cancel out, and we'll be left with 2x plus 7 equal a multiplied by x minus 1 plus b multiplied by x plus 2. We have to determine the numerical value of a and b. So let's start by determining the a. Remember, to determine the a or the b, we let x be any number, but by strategically letting x to be equal negative 2, we have negative 2 plus 2, which will be 0. 0 multiplied by b will be 0, giving us a window of opportunity to determine the numerical value of a. So we let x be negative 2. So we have 2 into negative 2 plus 7 equal a into negative 2 minus 1 plus b into negative 2 plus 2. And negative 2 plus 2 is 0. 0 multiplied by b will be 0. On the left, 2 multiplied by negative 2 will be equal negative 4 plus 7 equal a into negative 2 minus 1 is negative 3. And that will cancel out because 0 multiplied by b will be 0. So now, negative 4 plus 7 is equal positive 3. And we still have a multiplied by negative 3 on the right. Let's divide both sides of the equation by negative 3 to make a the subject of the formula. The numerical value of a will be equal 3 divided by negative 3, which is equal negative 1. Now let's determine b. So let's copy and paste that. So by strategically letting x to be equal 1, we can determine that b. So we have 1 minus 1, which will be 0. 0 multiplied by a will be 0, giving us a window of opportunity to determine the b. Substituting x for 1, we have 2 into 1 plus 7 equal a into 1 in the place of the x minus 1 plus b into 1 in the place of the x plus 2. 2 plus 7 is equal 9 on the left, and 1 minus 1 will be 0, and 0 multiplied by a will be 0, so we can remove this part. So we have now b into 1 plus 2, which is 3. So we are going to divide both sides of the equation by positive 3 in order for us to make the b the subject of the formula. So 9 divided by 3 is 3. So the numerical value of b is equal the 3. So now we substitute the a and the b, since we have our b is equal 3. So now let's have this a here. We copy and paste. So remember that by integrating the left hand side is just the same as integrating the right hand side. So the integral of this on the left is equal to the integral of what we have on the right, provided that we have the numerical value of a and b, of which we have. So we copy and paste this and substitute the values of a and b. So this will be equal the integral of, in the place of the a, we substitute the negative 1, which we divide with the x plus 2, plus b. In the place of the b, we substitute the 3, which we divide with the x minus 1. And we have that dx. Now we can integrate, or we can rearrange. So we have the integral of, we can push that negative 1 out, and we'll have 1 divided by x plus 2, and also push that 3 out, and we'll have 1 divided by x minus 1. Now we are at liberty to integrate. So we have this negative 1 multiplied by the integral of 1 divided by x plus 2. The integral of 1 divided by x plus 2 is the ln of the x plus 2 plus the 3 multiplied by the integral of 1 divided by x minus 1. The integral of 1 divided by x minus 1 is the ln of x minus 1 plus the constant c, and this will be our final answer. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.